Hello everyone. In the last video, we have already discussed what is the overall process that is working in ANN, and also at last we have discussed backpropagation. That according to backpropagation, we'll be updating the last layer weights, and after update all the last layer weights, then only we'll be moving on to the previous layer weights. That is, first we'll be updating all the weights in W2, and after updating all the weights in W2, then we'll be moving on to this particular W1, and after updating all the weights in W1, then we'll be moving on to W0, right? So this is what we have discussed in the last video, but I haven't discussed how exactly it is being done. So let's try to understand that in more detail in this particular video. Okay, let's try to take some small neural network that is shown over here. So here there is an input layer, and in this input layer there are only two inputs, that is x1 and x2, and then we are having a first hidden layer, and in the first hidden layer we are having three neurons, and that this I'm taking just for simplicity. And in second layer also we are taking three neurons, whereas in the output layer we are taking one neuron, and finally we are getting the output. Let's consider that we are trying to solve some kind of regression problem for simplicity. And you guys know, in the output layer, if it is a regression problem, what is the activation function that we'll be using? The activation function that we'll be using in the output layer is linear activation function. Okay, based on this particular regression problem case, let's see how the backpropagation is being done. It will work in a similar fashion for even it is binary classification or multi-class classification. Almost it will be working in a similar way, only the activation function will change a bit. Okay, so now let's try to move further. So basically we know that like the weights that are between input layer and hidden layer are denoted with this W0, and basically all those weights are this W011, W012, and W013, and similarly W021, W022, W023. So all these weights will be there in this particular W0. Okay, and similarly in W1 we'll be having all the weights. Along with those we'll be having bias terms as well. For now let's ignore that as well. So just for simplicity, our main goal of this particular video is to understand backpropagation. So let's try to simplify things as much as possible. We are only considering these weights for now. As of now we are thinking that there are no bias terms. So in W0 we'll be having only these 6 weights, and similarly in W1 we'll be having total 9 weights. And also see this particular notation. So here in the superscript we are having 0, that is denoting that it is between input layer and hidden layer 1, whereas if we are having superscript 1, that is denoting that it is between hidden layer 1 and hidden layer 2. And similarly if we are having superscript 2, that means that it is between hidden layer 2 and the output layer. So that is what this particular superscript is denoting, whereas these 1 and here 1 and here 1, that is denoting that this particular input and this particular node in this particular layer and the node in this layer, so both are 1. That means this one is getting connected to this one. That's why this is 1 and 1, whereas this is 2, second input, whereas this is the first neuron, right, is 2 1. So second and first, so it is 2 1, whereas here from 1 we are connecting to 2, that's why it is 1 2. Like that, in each of the layers we are denoting the weights with this particular notation. In the superscript we'll know which layer it is, whereas in the underscript we'll get to know which weight it is exactly. That information we'll be knowing by this particular notation, and this notation might change in different cases. Just for simplicity over here we are taking this particular notation. So just for this video, remember this notation. Okay, that is what I expect from you guys. I hope this is clear. Now we are having W0, W1 and W2, and these are the weight matrices which are consisting these weights. Okay, now let's try to write down the equations of O11, O21 and O31. So O11 is the output that we get from this particular neuron of hidden layer 1, and similarly O21 is the first output that we get from hidden layer 2, and similarly O31 is the final output that we are getting out of this whole neural network. Okay, so let's try to write down these equations. So in order to write these equations, so basically here these are all neurons, right? And we have seen in the perceptron video what happens and how output we will be getting. So this output is also having notation that this is the first output, this is the second output, and this is the third output. But all these outputs are corresponding to layer 1. That is what it is denoting. So superscript will denote which layer outputs are those, and subscript will denote like which neuron is giving that particular output. And similarly over here, this is second layer outputs, and this is the first neuron that is giving the output, and this is the second neuron that is giving the output, and this is the third neuron that is giving the output. And similarly over here. So that is the notation. And let's try to see what is the equation that we get out of this particular O1. So if we try to write down the equation, it is F1. What is F1? F1 is the activation function that we are using on this particular neuron, and F1 of what we'll be getting, we'll be getting x1 and x2. So those will get multiplied with the weights, that is W011 and W021. So here x1 is multiplied with W011 and x2 is multiplied with W021. So like that we'll be getting the equation of O11, and similarly O12 and O13 will also be almost similar. Okay, and just these weights will change. And similarly, let's try to see how O21 will be looking. And the similar fashion, O22 and O23 will be looking the same. Okay, so let's try to understand this. In case of O21, the activation function, let's say we are using F2 of O11. What is O11? O11 is this particular output. So this output will be given as input to the next layer, right? So that's why these O11, O21, O31 will be the inputs, and these inputs will get multiplied with some weights. So that is what we are observing over here. O11 is multiplied with O111, and similarly O12 is multiplied with O121, and similarly O13 is multiplied with O131. Okay, and in the similar fashion we'll be getting the output for this as well. And as it is a regression problem, we are using linear activation function. And what is linear activation function? Linear activation function is nothing but W of x equal to x. Okay, so that's why whatever output that we are getting over here, that will be passed as same over here. So it is not passed through any of function. We can think of it like that. So that's why directly our equation for O31 will be O12, that is this one, multiplied by this particular weight, and O22, that is multiplied with this particular weight, and O23, that is multiplied with this particular weight. So these are the equations, and I hope these three equations are clear for everyone. So if it is not clear, please pause the video and try to look once again. So try to observe this particular network and try to write down your equations by your own. Then you'll understand it better. Okay, so once you understood this particular equations, then go forward. So let's move further. The output that we are getting over here, it is the predicted output actually. So this is our predicted output, and this predicted output we will be getting by doing forward propagation on the inputs that we pass. So here we'll be passing some of our inputs, and after passing all of these inputs, we'll be getting the predicted output over here, right? And this predicted output, where we'll be passing, the next step is the loss function. First step is our hypothesis. This whole network is our hypothesis, right? And what is the next step? Next step is our loss function. And if we are solving some regression problem, what is our loss function? If you guys remember, the loss function is mean squared error, and the formula for that will be 1 by n, summation of I from 1 to n, y minus y cap whole square. And what is this n? This n is nothing but number of training data points. This we have discussed long back. Just try to remember or recollect all the videos. Okay, this n is nothing but number of training data points, and here this is our actual output, whereas this is our predicted output. And from where we will be getting this predicted output? This predicted output will be getting it from this particular network that we are having. Initially we'll be initializing all these weights with some random values, so we'll be getting some random output initially. So as we are getting random output, we are comparing it with actual output that we have in the dataset, actual dataset. And as we are comparing these two, initially the loss will be very high, right? So that is what loss function is. Why loss function is there? Loss function is there in order to specify the amount of loss that our model is making. So that is what it is doing. So we are comparing our actual and predicted, and we are getting out the loss that it is making. if it is classification problem, we already know that in case of binary classification problem, we will be using binary cross entropy as our loss function. And if it is multi-class classification, we'll be using categorical cross entropy. So just for information, I'm telling over this, but as of now, we are solving regression problem. For regression problem, this will be our loss function. The next step after loss function is optimizer. And in case of optimizer, till now we have used only gradient descent, and we'll see there are so many other optimizers. For now, let's consider this as gradient descent only. So what is the formula for gradient descent? The formula for gradient descent is theta nu equal to theta old minus alpha times loss with respect to the theta. So this is our exact formula that we have seen from long time, right? So the same formula will be used, where what are these thetas? These thetas are nothing but parameters. And who will adjust these parameters? These parameters are adjusted by machine learning model or the deep learning model that we are having. Okay, so let's see how it is adjusting. So in case of our neural network, what are our parameters? We have discussed this maybe multiple number of times by now. That is W0, W1 and W2. So all the weights in W0, W1 and W2, all these will be our parameters. Okay, so let's try to see how these parameters are getting adjusted. So this is the most interesting part, or this is the main part of backpropagation. So let's try to look into it in more details. So like whenever you didn't understand anything, please try to pause and rewind it back and try to check it out, because some of you might be going through this backpropagation video for the first time. It might be a little bit difficult for you, so that's why try to go into this as slow as possible. Basically in W21, what are the weights that are available with us? That is W211, W221 and W231. Those are all these three weights that we are seeing over here. Okay, so that is what we'll be having in W2. And for each weight matrix, I'll be explaining only one weight, how one weight is getting updated. In the similar fashion, all other weights will also get updated. Okay, so if you are trying to understand one weight, then it is almost the same for other weights also. So that's why I'll just explain for this weight in W2 and this weight in case of W1, this weight in case of W0. So once you understand how these weights are getting adjusted, that is W011, W111, W211, then you'll understand how all other weights are also getting adjusted. Okay, so that's why let's try to understand this. If you understand this, then obviously it is same for W221 and W331. And similarly, if you understand for this, for all other weights also it's the same. And if you understand this, for all these weights also it is almost the same. Initially we are having W211 and we are trying to update that. So W211 equal to W211 minus alpha, this is our alpha, and we are doing partial derivative of loss with respect to the theta. So here our theta is W211, and what is our loss function? Our loss function is this particular mean squared error. And in mean squared error, what we are having? We are having actual output minus predicted output whole square. And what is our predicted output? Our predicted output is nothing but O31. And what is O31? O31 is O21 times W211 and O22 times W221 and O23 times W231. So that is what we are writing over here. So I am keeping y minus this instead of this y cap. I am just writing this particular O21 times W211. Right, that is nothing but this equation I'm writing over there. So I hope this is clear. And once it is done, here we'll be having square. Okay, so let's for now ignore this one. So if n is some constant in general, so let's take it as 1, or let's ignore this for now. So if we are ignoring this, we are left with this particular function, that is y minus O21 times W211 minus O22 times W221 minus O23 times W231. So that is because this minus will go inside and all these pluses will become minuses. Okay, so this we are doing partial derivative with respect to W211, and this W211 is clearly available over here. And if you remember some derivatives, like in your intermediate or 10th class you might have studied, right? So if you have just some basic idea of derivative, You guys know, right? So whenever we are trying to do derivative like this, in all these things, this particular W21 is not there. As it is not there, these will get removed automatically, or these will become 0, and only will be left with this one. And as this is the one that we are having, this will be getting as our output, that is minus O21 times, we'll be doing some partial derivative on this as well. So within this also, if this weight occurs, then we'll be getting something out of it. But for now, let's ignore this. Let's say this is some constant value, for suppose. If this is some constant, then the output that we'll be getting out of this one is minus of O21, right? And like this we'll be getting when we are doing it with W211. And if you are doing it with W221, then what we'll be getting? Instead of this minus O21, we'll be getting minus O22. And if you are doing it with W231, then instead of O22, we'll be getting O23. Like that, for all these weights, the partial derivative or how this weight is getting updated will be the same. Okay, so I hope this is clear for everyone till this point. So like that, updation of these W2 weights is really simple. So it is not at all complicated. It is just applying some derivative over there. Okay, simple derivative. But if we go forward, or if we go backward in this particular neural network, so till now we have only seen, or we are only trying to see the last layer, that is W2. Once we go forward, then some complexity occurs. So let's see how this complexity will look like. Now we are trying to update the weights of W1. We have already updated, let's say, all the weights of W2. Now we are trying to update the weights of W1. And here I'm just writing directly this particular equation. We have seen how this all thing occurs. So I'm writing all directly this particular equation. And here, if you observe, in this equation, we are not able to see this W111. We are not able to see in this particular function directly. But whereas here, we are directly able to see this W211 that is present over here. But here, we are not able to see W111 anywhere, right? If you carefully observe where this W111 will be there in the neural network, it is present over here. So this weight is contributing to this particular output, that is O21. And O21 is a function like F2 of something, right? What is O21 equation? O21 is F2 of O11 times W111. Here we are having this W111 and W12, W121 and O13, W131, right? So this is the equation of O21. So that is getting multiplied with this particular W211. But here we are not able to directly see this, right? So that's why we need to go into this. And how we are going into this, that we do with the help of chain rule. So according to chain rule, let's say we are having a function y equal to f of x, and this x is function of t, let's say. Then if you are doing partial derivative of y with respect to t, that will be divided in this format. First we'll be doing partial derivative of y with respect to x, and after doing this, then we'll be doing the partial derivative of x with respect to t, and we'll be multiplying both of these. So this is simple chain rule of derivatives or partial derivatives. So this chain rule we'll be using over here. So here, as we are interested in only this, because our W111 is present in this only, that's why I'm trying to write only this, and extra terms will be there, but only we are interested in this one, that's why I'm writing only this. So just for your simplicity. And so here, if you observe, this O1 I just expanded and wrote over here. So this is F2 times O11 times W111. Now we are able to see this, right? But it is within some other function. So that's why we should consider this as some x. And first we'll be doing this x, that is this whole function, we'll be partially derivating it with F2, that is this particular function. Okay. Once we did the partial derivative of this particular F2, then we'll be going into this. Once we are into this, then we'll be doing the partial derivative with respect to W11. I hope this is clear. And if it is not clear also, just remember that this main thing, that is, first we'll be updating all the weights in W2, then we'll be updating all the weights in W1, then we'll be updating all the weights in W0. Okay. And while doing this, it will be using the chain rule of partial derivatives. And according to chain rule, what it will be doing, first it will be partially derivating it with this particular function, and once it do partial derivative with this, it will go into this particular function where this W111 is directly available, and on doing this we'll be able to obtain some value, and once we get that particular value, we can be able to update this W11. Okay, so like that, W11 will get W111 will get updated, and all the weights in W1 in the similar fashion will get updated. Now let's see how this W011 will get updated. So basically, as I said, till this part everything will be the same. So till this point everything will be the same. Now, as I said, here we are having, like, here we are interested in W011, right? So W011, W011, and W011. Here also we are not having W011, so we have to go into it. So this O1, if we expand, it will be f of 1 times W01, W011. So like, we are having initially one function, within that we are having another function, within that we are having this W011. So first we are trying to go into this particular f2 function. Once we are into this f2 function, then we are again trying to go into this f1, and once we are into this f1, then we are doing partial derivative with this W011. Like that, we'll go till we reach to this particular weight. So that's why we'll be doing it in order. While we are doing it in order, what will happen? We have already pre-computed this W like partial derivative of x with respect to f2, that is repeating over here, right? And similarly, like, if we are having more number of layers, then this will be even more. The number of repetitions of this and this and this, like that, these repetitions will be occurring too many number of times. So simply, instead of calculating them multiple number of times, we can save them once we get, like, once we calculate this, we can save somewhere. It's like doing some DP problem. So in DP, instead of calculating the sub problem again and again, what we'll be doing, we'll be saving the output of that particular sub problem, and we'll be using it further whenever it is getting used, right? So that is the idea of DP. So the same thing we'll be using over here. We'll try to save these partial derivatives information once it gets calculated, and whenever in future the same partial derivative is getting used, we'll be directly using that particular value. Okay, this is what is happening in case of backpropagation. You got some clear idea. Okay, so some of you might not get in one go. So if you are not getting it, like, please go through the video once again. And if you have any kind of doubts, please comment down in the comment section. I'll try to help you out. So that's it for this video. Thank you everyone. Bye bye.